Alright, so today we are going to talk about the unit circle and reference angles, and hopefully by now you guys have a copy of the unit circle on your desk. Okay, you need to make sure that you always have a copy of this and you always have it with you. This is what you're going to have to memorize for pop quizzes as well as for the quiz and test. So just the basic structure of the unit circle. We talked about 30, 45, and 60 yesterday. Now, basically what happens as you go around the unit circle is just keep adding those increments. So if we start at 90 and add 30, that gives us 120. 90 plus 45 gives us 135. And 90 plus 60 gives us 150. And notice again, if we start at 180 and add those increments, and from 270, add 30, 45, and 60 again. So basically, around the entire unit circle, we are making special right triangles due to those angles. Okay. Now, yesterday we talked about these values. Okay. And notice that they just keep repeating themselves. So if we look at the x values, I have root 3 over 2, 2 over 2, and 1/2. And then when I come to the other side, I have negative 1/2, negative root 2, negative 3 over 2. And I repeat, negative root 3 over 2, negative 2 over 2, and negative 1/2. And then 1/2, 2 root 2, and root 3 over 2. So notice that the x values kind of just duplicate, but they just change signs depending on which quadrants you're in. So this is positive, positive. Quadrant 2 is negative, positive. Quadrant 3 is negative, negative. And quadrant 4 is positive, negative. Okay, and the reason why these values just keep repeating is because we are creating 30, 60, 90 triangles. So here would be the 30 degree, 45, 60. And then if we came to the other side, we would have, there's 60, 45, 30. Okay. So as you go around the unit circle, you just keep recreating those triangles. Okay, so once again, make sure that you guys always have these on you. You've already learned the quadrantal angles, and now we're just going to add the rest of the unit circle in. Okay. All right, so let's talk about a reference angle. So reference angle for angle theta is written as theta prime is the positive acute angle made by the terminal side and the x-axis. So a couple key things to remember about reference angles. The first is that reference angles are always positive. Okay. And because they are acute, reference angles are always less than 90 degrees. Okay. And then you always draw to the x-axis, kind of like we did with our triangles in the previous chapter. Okay. Reference angles tend to be something that students forget come time quiz and test time, so just make sure that you keep reviewing what a reference angle is. It's positive, it's acute, and it's always drawn with respect to the x-axis. So if we look at these examples, if we're in quadrant 1, then the reference angle is whatever theta is. So we have theta prime for the reference angle. Okay. If we're in quadrant 2, we always draw it with respect to the x-axis. So here is the reference angle. Okay. For quadrant 3, once again, we draw it with respect to the x-axis. And quadrant 4, there would be the reference angle. Okay. Notice that all of these angles are going to be less than 90 degrees. Okay, and we make sure that they are positive. So how do we find reference angles? Well, if you're in quadrant 1, as stated in the diagram, the reference angle is whatever theta is. So reference angle is just theta. Okay. If we're in quadrant 2, Okay. Quadrant 2 is at 180 degrees. And I want to take away theta. So the reference angle then is going to be 180 minus theta. Okay. Then for quadrant 3, we're at 180 degrees, and then all we need to do, okay, is find that little piece. So we would take theta minus 180 degrees. Sorry, let me erase that. That doesn't look very neat. So theta minus 180 degrees. Okay. And then if you're in quadrant 4, to find the reference angle, you take 360 degrees and you subtract theta. Now, that's kind of a lot to remember, so one way you can do this is just always think how many degrees away are you from the x-axis from the terminal side. Okay, so this is a good question you can always ask yourself if you don't really feel like memorizing all those formulas. Okay. So if we're in quadrant 3 because of a 245 degree angle, so here's our angle. That's theta, that's 245 degrees. Okay. And we want to know the reference angle, which is from the x-axis and the terminal side. So how many degrees away are you from the x-axis? Well, the x-axis is at 180, so 180 has to be taken away from 245. And you should get 65 degrees for your reference angle. Okay. So once again, when you're finding the reference angle, it's how far you are away from the x-axis. Okay. So you can memorize the formulas. When you're in quadrant 3, you take theta and you subtract 180. Or you can just figure out how many degrees you are away from the x-axis. Okay. If we look at the second example, we're in quadrant 1. And when we're in quadrant 1, the reference angle is the same as theta. So 79 degrees. Okay. If we look at the third example, we're going to be in the second quadrant. So this is 163 degrees. And I want to find the reference angle from the terminal side to the x-axis. So if the x-axis is at 180, I take 180 minus 163, and I get 17 degrees. Okay. All right, go ahead and take a moment and try number 4 on your own, please. Okay, share with your partner. And hopefully you guys got 38 degrees. Okay, for that one you take 360 minus theta. Okay. All right, so let's move on to the next part. We're not going to have these notes today, but we will get to part of part 2. Okay. So if theta is greater than 360 degrees, or is negative, then we first have to find the smallest positive coterminal angle. So we're bringing back material from last chapter. Okay. And then after we find the smallest positive coterminal angle, then we find the reference angle. Okay. So for example, number 1 is at negative 100 degrees. So this is a negative angle. So I'm going to want to find the smallest positive coterminal angle first. Okay. So I'm going to add 360 to that so that I go in the positive direction, and that will get me 260 degrees. So we're good to go. So that places us in quadrant 3. So we want to go back to 180 degrees. So 260 minus 180, and you get the reference angle to be 80 degrees. All right, example number 2. So first we have to find the smallest positive coterminal angle. So if I subtract 360, I can still go one more rotation. So I'm going to subtract 720 and get 130 degrees. Okay. That puts us in quadrant 2. So in quadrant 2, we want to try to get to 180 degrees. So 180 minus 130 gives me a reference angle of 50 degrees. Okay. All right, go ahead and try 3 and 4 on your own, please. All right, share with your partner. And for number 3, you guys should have gotten 30 degrees. And for number 4, you should have gotten 53 degrees. So for number 3, you add 360 to be positive, which is 30 degrees, which puts you in quadrant 1. And when you're in quadrant 1, the reference angle is the same thing as whatever theta is. And then for number 4, you had to subtract 360 a few times, landed in quadrant 4, so 360 minus 307, you guys should have gotten 53 degrees. All right, so now we are going to move on, and we're going to use reference angles to find exact trig values. You cannot use your calculator for this. Sorry, it's a little crooked. Okay, that's about as good as it's going to get. All right, so if we draw where 120 degrees is, okay, so that's 120 degrees. We want to find sine, cosine, and tangent based off of its reference angle. So we first need to find its reference angle, which is going to be 60 degrees. Okay, because 180 minus 120 is 60 degrees. And we always write that reference angle close to the origin. So you wouldn't write it out here. You write it whichever angle is connected to the origin. All right, so just like yesterday, we are going to fill in the information. So we know r equals 1. And then across from the short leg is going to be 1/2. And then across from 60 is root 3 over 2. Okay. But before we move on with finding in the information, we have to be careful. We are actually in quadrant 2, so that's going to make the x value negative, so that's a negative 1/2. Okay. So then y equals root 3 over 2, and x equals negative 1/2. And now we can find all the information. So sine of 120 degrees is whatever the y values, which is root 3 over 2. Cosine of 120 degrees, which is the x value, which is negative 1/2. And then the tangent of 120 degrees, so that's going to be root 3 over 2 divided by negative 1/2, which gives us negative root 3. Okay. Remember that tangent should be negative in the second quadrant because the only trig ratios that are positive is sine and its reciprocal of cosecant. Okay. So basically what we're doing is we're drawing the angle in, finding its reference angle, and then using that 30, 60, 90 triangles from yesterday and the 45, 45, 90 to fill in the rest of the information. All right, let's do example 2 together. All right, so let's draw in still. And we're going to draw in our reference angle, which is draw in our regular angle, which is 210 degrees. Okay. Then our reference angle is going to be 210 minus 180, so sorry I didn't leave much room right there, but that's going to be 30 degrees. Okay. So R is still 1. Okay. And then across from 30 degrees is 1/2. And then across from 60 is root 3 over 2. Okay. Hopefully, some of you are starting to go, well, wait a minute. We are in quadrant 3. So that's going to make both our x and y values negative. Okay, so y equals negative 1/2 and x equals negative root 3 over 2. So once again, we drew in our angle, created a 30-degree reference angle. Okay, across from 30 is the 1/2. And the other side is going to be root 3 over 2. But because we're in quadrant 3, the both values are negative. So sine of 210 degrees is negative 1/2. Cosine of 210 degrees is negative root 3 over 2. And then tangent of 210 degrees, and because we're in quadrant 3, that means tangent's going to be positive, is root 3 over 3. Okay. If you're not sure how I got that, then check your notes from yesterday on how we rationalized when we did negative 1/2, or in that case 1/2 yesterday, divided by root 3 over 2, and how we rationalized that. All right. I want you guys to go ahead and try on your own. Example number 3. We are going to do 4 and 5 tomorrow, so if you could just work on 3 right now, please. All right, go ahead and start sharing your answer with your partner, and I'm going to start drawing the diagram up on the board for you. So go ahead and talk now, please. All right, so when you drew in 315 degrees, you should have landed in quadrant 4 and created a 45-degree reference angle. So when we have 45 degrees, remember that both legs are root 2 over 2. But because we are in quadrant 4, the y value is negative. So y equals negative root 2 over 2, and x equals positive root 2 over 2. So sine of 315 degrees equals negative root 2 over 2. Cosine of 315 degrees equals root 2 over 2. And then tangent is the ratio of y over x. When you divide something by the same number, it's just going to be 1, but since we're in quadrant 4, that's going to be negative 1. Once again, think about why that makes sense. Okay. In quadrant 4, only cosine and secant are positive, so the other trig ratios have to be negative. Okay? All right, so that's all for today. You guys have the remainder of the time, which isn't too long of assignment, to do your homework. It's just a suggestion for problems, I think it's 10 through 17. I would make a table and then just fill it in that way, or you just can do all the problems individually. Okay? All right, if you guys have any questions, please email me. Otherwise, I will see you guys tomorrow. Thanks, and have a great day.